Good morning, students. Today I am going to discuss the vector addition, in which first I will discuss the triangle law of vector addition. Let the two vectors p and q be represented both in magnitude and direction by the sides AB and BC of the triangle taken in same order. Then according to the triangle law of vector addition, the resultant R is given by the closing side AC taken in the opposite order. Now, for finding out the magnitude of this resultant, I have made a diagram here in which I have drawn a perpendicular C which is meeting AB at point E, and the angle CBE is equals to theta. Then from this right angle triangle AEC, in right angle triangle we know from Pythagoras theorem AC square is equals to AE square plus CE square, which can be written as, from the figure we can see that AE is equals to AB plus BE, so it can be written as AB plus BE whole square plus CE square. On further solving we will get AB square AB square plus BE square plus twice AB BE plus C square. Now from this smaller triangle, applying the Pythagoras theorem on this, we can write BC square is equals to BE square plus C square. Now in place of B square plus C square, we can substitute BC square. So this equation will reduce to AC square is equals to AB square plus BC square plus twice AB into B. This can be written as equation number 1. Now from the right angle triangle BEC, if you calculate cos theta, then cos theta will be equal to B upon BC. From here we can write B as BC cos theta. Substituting the value of B in equation number 1, we will get AC square is equals to AB square plus BC square plus twice AB into BC cos theta. As we know that AC is equal to R, AB is equals to P, and BC is equals to Q. So as we know AC is equals to R, AB is equals to P, and BC is equals to Q. So we can write the above equation as R square is equals to P square plus Q square plus 2PQ cos theta, or R is equals to under root P square plus Q square plus 2PQ cos theta. This is the general formula for calculating the resultant of two vectors which are making an angle theta with each other. This can be written as equation number 2. Now we have calculated the resultant of these two vectors p and q. Now we want to find the direction of this resultant from AB. Let the resultant makes an angle beta with this P. Then from triangle AEC we have tan beta is equals to CE upon AE or CE upon AB plus BE. It can be written as equation number 3. Now sin theta is equals to, if you calculate sin theta, the value of sin theta is CE upon BC, or from here we can write CE as BC sin theta. Now putting the values here, we will get tan beta is equals to CE we have calculated, that is BC sin theta upon the value of AB as it is, and the value of B is BC cos theta. BC represents vector Q, so it is Q sin theta upon P plus Q cos theta. This can be written as equation number 4. This is the formula for calculating the direction of the resultant from this vector P. Now we have certain situations in which we can calculate the resultant. Taking the first situation, when theta is equals to 0. Theta is equals to 0 means the vectors act along the same direction, means the vector P and Q are in same direction, or it can be represented like this. This is vector P and this is vector Q. Then the resultant R is given by R is equals to under root P square plus Q square plus 2PQ cos 0, or we will get R is equals to under root P plus Q whole square, which is equals to P plus Q. And also we can calculate tan beta, which is equals to Q sin 0 upon P plus Q cos 0. Means in this situation beta will be 0 degree. It means that when theta is equals to 0, or the vectors act along the same direction, then the magnitude of resultant is equal to sum of magnitude of two vectors. We can represent R here, which is equals to P plus Q, and the direction, it acts along the direction of vector P and Q. Now coming to the second situation, when theta is equals to 90. Means when the two vectors act right angle to each other, then r will be equal to under root p square plus q square plus 2pq cos 90, or we will get under root p square plus q square. In this situation, the resultant will be calculated by this, and the angle between them is given by tan beta is equals to q sin 90 upon p plus q cos 90, which will be equal to q by p. For this, a situation is like this, as the p is acting in this direction and q is acting in this direction. Then the resultant r will be given by r is equals to under root p square plus q square, and the direction is given by tan beta is equals to q upon p. Now we have another situation in which theta is equals to 180 degree. This means that the two vectors, here we can see one vector is acting in this direction p, and the another vector is acting in the opposite direction. Then the resultant r is given by p square plus q square plus 2pq cos 180, which is equal to under root p minus q whole square or p minus q, and the direction tan beta is equals to q sin 180 upon p plus q cos 180, which is equal to 0. This means beta is equals to 0 or 180 degree. This is just a situation like this, a vector p is acting in this direction and the other vector q is acting in the opposite direction. Then the resultant r will be given by p minus q. It is r, which will be equal to p minus q. The direction of the resultant will depend that which one is greater. If p is greater, then the resultant will be along the direction of p. If the value of q is greater, magnitude of q is greater, then the direction of this resultant will be along q.